In this episode, we're going to look at how to do subnetting. I'll show you how to do it and have a discussion of those concepts along the way. In this activity, we're going to be given an IP address of 192.168.100.0/24 to subnet and provide the IP addressing for our network. Each LAN in the network requires 25 addresses for end devices, the switch, and the router. The connection between our routers will require an IP address for each end of the link. We'll be discussing designing an IP addressing scheme, assigning IP addresses to networking devices, and then verifying network connectivity. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. .7.5 subnetting scenario. Got the packet tracer lab open up. On the left side is our main window where we have all our devices. That's where we'll do our configuration. On the right side, bottom right, I have the normal packet tracer window. That'll allow us to check our results as we go through and do some configurations. The upper right is the Word document of the packet tracer activity window. This allows me to enter my work into the fields. I got to fill out the addressing table. I have to answer some questions. Word document allows me to do that. Here's our addressing table. As you can see, it's blank. We're going to have to go through and fill this all in. We need to calculate the different subnets, requirements, find out that information. Here's our objectives. Part 1, design an IP addressing scheme. 2, assign those addresses and verify network connectivity. We're gonna design our subnetting. Once we do that, then we're gonna go and we're going to apply that following the rules they give us. We are given the network of 192.168.100.0/24. It's a Class C address we are given. The subnet and provide IP addressing for this network over here. As you can see, this network, we have several devices on it. Each different network has requirements of at least 25 hosts. Do that. Got a switcher. It has a switch and a router interface. Connection between R1 and R2 will require addresses. So this connection right here, we also have to go through and assign IP addresses. Part 1, Step 1, subnet the 192.168.100.0/24 network into the appropriate number of subnets. We're going to go back. We're going to think about what the formula is. The formula is 2 to the number of bits borrowed for our subnets to make smaller subnets. That equals the number of subnets there. First question, 1A. Based on the topology, how many subnets are needed? Looking over here, we have different networks. And remember, routers are the edge of the network. Switches connect devices up. They make your network. They make your local area network. But when we hit a router, that's our default gateway. That's the exit on and off of our network. When we get to a router, that is a connection to a different network. So routers basically stop networks, local area networks. Here in our diagram, the upper left, the PC1, switch 1, and then this interface, gig 00, that is the first exit. Notice I'm not getting all of R1 in there. I'm just getting the gig 00 interface. That is one network. Second network, right here. PC2, switch 2, and once again the interface on R1. That is our default gateway. Gig 01 is our default gateway. That is part of our network. The third network, right here, once again is 25 hosts. It has PC3 in it, switch 3, and the gig 00 interface from R2. Now it's not the entire R2. It is just the gig 00 interface. The fourth network is right here. Once again, that has 25 hosts, PC4, switch 4, and the gig 01 interface off of R2. That is the fourth network. The fifth network is the network that connects up these two routers. You need a network between them so we can route traffic. This is our 5th network right here. And so we had 1, 2, 3, 4, 5 networks. Five subnets. Oops. 5 subnets total. 4 for LANs. 1 for the WAN from R1 to R2. How many bits must be borrowed to support the number of subnets in the topology? How many bits must we borrow from our IP address with the subnet mask there? Once again, the /24 means we can't do anything with the first 3 octets. We can't do that. Our ISP, our network administrator said, this is the network you're using. You can't do that. But this last octet, these last 8 bits, we can do whatever we want there. And that's where we're going to subnet, create our smaller networks to allow us to give us our 5 networks. The formula for that, once again, is 2 to the power of bits we're borrowing to make our subnets. That equals the number of subnets. And so 2 to the number of subnets, that equals, 2 to the number of bits borrowed, that equals the number of subnets. And what I'm going to do is I'm just going to work through here until I find one that meets our requirement of 5 subnets total. 2 to the first, that equals any number to the first is that number itself, that equals 2 subnets. So when I borrow 1 bit, that is 1 bit from this portion, so I now have 1 bit in the subnet portion, 7 bits in the host portion, that gives me 2 subnets. But I need 5 subnets total. That doesn't work. If I go 2 to the second power, that is 2 squared, or 2 times 2, that equals 4. And once again, that's subnets. If I borrow 2 bits here, that is 2 bits out of these 8 bits. 2 bits that goes into our network portion, we're borrowing that. That leaves us 6 bits in our host portion. 2 to the second power, that equals 4 subnets. 4 subnets is less than the 5 required. So borrowing 2 bits does not work. 2 to the third power, that equals 2 times 2 times 2 equals 2 times 2 is 4 times 2 is 8. That gives us 8 subnets. That 8 subnets is more than our 5 networks. So we can borrow 3 bits. Of these 8 bits that we can work with right there, 3 bits are going to go into our network portion. 5 bits are going to remain in the host portion. How many bits must we borrow? We must borrow 3 bits. How many subnets does this create? If we borrow 3 bits, how many does that create? Once again, that formula was 2 to the number of bits borrowed, so 2 to the third power equals the number of subnets. That was 2 times 2 times 2. That gives us 2 times 2 is 4 times 2 is 8. That gives us 8 subnets. How many usable hosts does that create per subnet? Okay, that was another formula. That formula was 2 to the number of host bits. Notice I'm using H there. Gives us the number of IP addresses, but we need usable IP addresses. And you can't use the first one because that's the network address. You can't use the last one because that's the broadcast address. So we have to subtract 2. That gives us the number of hosts per subnet. As we look at this, we are borrowing 3 bits right here. If we borrow 3 bits of this 8 bits we can work with, that gives us 5 bits left in the host portion. And so our formula comes in here, 2 to the 5th minus 2. That gives us the number of hosts per subnet. And so that's 2 times 2 times 2 times 2, 5 times there, minus 2. That is equal to 2 times 2, sorry, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That gives us 32 minus 2. That gives us 30 hosts per subnet. Once again, that means for our 8 subnets, when we borrow these 3 bits here, that gives us 8 subnets. Each of those subnets will have 30 hosts per subnet. On to, should be E. But here I got A, probably your E. Calculate the binary value for the first 5 subnets. The first 2 are done for you. Now, once again, we are borrowing 3 bits. I'm going to go ahead and I'm going to highlight that. This is our network portion here. These are the bits we're borrowing. The first subnet, we start with putting all zeros into that. That gives us the network portion of our first network. The second network, we add 1 to these 3 bits. We have 0, 0, 0. We add 1 to that. That gives us 0, 0, 1 at that point in time. And when we figure out the value of that, the network address always ends in all zeros. And so as we work through here, these are always going to be 0. We can go ahead and fill that in right away. Time to find the value, the network address for our third network. Remember, computers start counting with 0. Our first subnet number 0 there. Our second subnet is subnet 1. Our third subnet is subnet 2. That's the one we're working on. What we do, once again, is we increment this by 1. Go ahead and add 1 to 0, 0, 1. 1 plus 1, that gives us 2, but in binary, we only have 2 possible values. We have 0 and 1. Can't have that, so we start over and we increment the next column by 1. Fill in leading zeros. That gives us our value here for our network address for the third network. For the fourth network, we take this value again, we add 1 to it. 0 plus 1 is 1. We're not doing anything else with the rest of these columns, so those values transfer down. That is the value for the fourth network, subnet number 3. Figure out the value for the fifth subnet. We add 1 to this value here. 1 plus 1, you can't have 2, so we start over. Increment the next column by 1. That gives us 1 plus 1 here again. Can't have 2, so we start over at 0. Increment the next column by 1. That is the value for this. That fills in our chart there. My B, your F, it says calculate the binary and decimal value of the new network interface. Once again, the subnet mask is all ones. It starts with all ones. Those ones mark the network portion, followed by all zeros. Those mark the those mark the host portion. We are borrowing 3 bits here. So now we have these 3 additional bits in the network portion. Network portion, once again, is represented by 1s, and that gives us a 1 here, a 1 here, a 1 here. These were the 3 bits we are borrowing. I'm going to highlight them again so they stand out. They get 1s. The host portion here, they get 0s. That is the binary value of our new subnet mask. Convert that into decimal. When we convert that into decimal, we look at our values here. And I'm just going to go ahead and I'm going to actually put in the values of these columns right here. That's a value of 1. This is a value of 2. That'd be 4, 8. Oops. That would be 16. That would be 32. That would be 64. And that would be 128. Now, to convert these 8 bits, the last octet, into binary, you take the values of where there's ones, you take the column value right there, 128, and you add them together. So 128 plus 64, that gives us 192, plus 32 onto that, that gives us a value of 224. That is the decimal value of our new subnet mask. 255, 255, 255.224. Fill in the subnet table, listing the decimal value of all available subnets, the first and last usable host address, and the broadcast address. Repeat until all addresses are listed. Okay, so getting started here is a little interesting. What we do here is the subnet address. Well, once again, the first 3 octets in our address, we can't change anything. That was given to us by our network administrator, by our internet service provider. These are the first 3 octets. That is the /24. We cannot change anything. And so that value will remain constant down here for our new subnet addresses. 192.168.100. And then this is the values we're figuring. And these are the values of the smaller network. I'm just going to go ahead, copy, paste those all in. I'm just going to go ahead and fill up the chart. The subnet address. Well, the first one, that starts with 0. And what we're doing is, I'm going to copy this table here and hopefully explain this. No, what we're doing here is we can actually go up to this table. This is our subnet 0, our first subnet. This was the network address. This is where we start off with 000. Now what we do is we take all 8 of these bits with our network portion we calculated, take all 8 bits, convert this into decimal. This one's pretty easy. All zeros is 0. That gives us our value here. Then we look at our second network. Once again, these are the 3 bits we're borrowing. We incremented it from 1 from the previous network. That gives us from 000, we add 1 here. That gives us this value here. Then we take all 8 bits, convert that to binary. The values here once again, and I'm just going to go ahead and type these in again. I think that helps. The column values, 8, 16, 32, 54, and 128. We are working on the second network, subnet 1. This was the next address there. The next address is 001. Network addresses have all zeros in the host portion. We take the 3 bits we borrowed, we take the 5 bits, we put all zeros in there, and then we convert this all to a decimal notation. We notice that we only have a 1 in the 32 column. Wherever there's a 1, we take those numbers, add them up, but we only have 1 1 in there, and value of 32. That gives us the network address right here, .32. Then we move on to the third network. The third network, once again, we take the network value from here, we add 1 to that. 1 plus 1 is 2, but there's no 2 in binary. We start over at 0, increment the next column. That gives us these 3 bits. 3 bits we're borrowing. The host portion is all zeros. We take and we now convert this into binary. There's only a 1 in the 64 column. That is the value of that column, is 64. Now we are working on subnet 3. the fourth one. This is subnet 3 right here. Once again, we added 1 to this. That gives us 0, 1, 1 in the network portion, the 3 bits we're borrowing. Host portion gets all zeros. We convert this into decimal. When we convert that into decimal, we have a 32, we have a 64. So 32 plus 64, that gives us 96. That is the value of this column. As we look here, notice there's a pattern. Each subnet address, each network address here, this is 0. The difference between 0 and 32, that's 32. Difference between 32 and 64, that's 32. The difference between 64 and 96, that's 32. What we're doing is we're adding 32 in here. For me, what I do is I do the first 3, 4, maybe even 5. Here, the 5th network right here. Once again, we add 1 to the 4th network bits. 1 plus 1 gives us 0. Carry the 1. 1 plus 1 here again from the 1 we carried. That gives us 0. Increment the next column by 1. Take those 3 bits, add in 5 bits of the 0. That gives us 1, followed by all zeros. That is 128. You can go ahead and fill that in, which once again, 96 plus 32, that equals 128. And what I do typically is I just go through, I do the first 2, 3, 4, 5 maybe, figure out what this is, and I just continue the pattern. So 128 plus 32, that is 160. 160 plus 32, that is 192. Then 192 plus our 32 here, 192 plus 32, that is 224. 224 plus 32, that gives us 256. Now remember, all ones, if we were to fill in all ones here, that is 255. 256 means you are over and beyond that. And so this is not part of our network. This subnet 8, the 9th subnet, is not part of our network. And so we only have 8 possible networks, which if we scroll up here, how many subnets does that create? That creates 8 subnets. That's what we're getting here, 0 through 7, or 8 subnets. For me, filling in the rest of this chart is easy, filling this in. What I do next is figure out what my broadcast address is. My broadcast address is 1 less than what my network address is. And so this is my network address. I'm going to go ahead, I'm going to copy this, paste it up here. And 1 less than my network address is my broadcast address. So it's a .31. And I can continue on. The next network address for this one is a .64. That means we have a .63 there. And like I said, these values, the first 3 octets, they're set by your internet service provider, set by your network admin. So you can go ahead, fill those in right away. And what I do is I just look at the value network address of the next network, subtract 1 from it. So that's a 64. That gives us 63. Down we have 95, 127, 159, 192, 223, but we don't have a value here. We don't have the value here. What happens is when we get down to our subnet 7, our 8th subnet mask, we have a 111 here in the broadcast address once again. That's what we're looking here. The broadcast address, the host portion is all 1s. If we have all 1s here, the host portion is all 1s. That gives us 8 1s. And so the last value here should be a 255. What's left here is to fill in the first usable host, the last usable host address. Once again, you can't use the first IP address. That's the subnet address. That's the network address. You can't use the last one. That's the broadcast address. You can't use these 2. What you have to do is use 1 more than this. And so that gives us 192.168. 100, and you add 1 to this. That gives us our first usable, so 0 plus 1. Last usable is 1 less than the broadcast. That gives us 192.168.100.30. 192.168.100.30. That is how I fill this out. And as we work through here, once again, the first 3 octets, they're all going to be the same because we got that from our ISP. So I'm just going to go ahead and fill those in. Fill those in here too. And now all I have to do is add 1 to this to give me my first usable. And so that's a 33, 65, 97, 129, 161, 193, and 225. The last usable address is 1 less than the broadcast address. So I can take the value in the 4th octet, subtract 1. That gives me my last usable. This is 63. That would give us 62 for the second network. Third network is 95. Subtract 1 is 94. 126. 158. 191. 222. And subtract 1 from 255 gives us 254. Last usable address. That is now filled in the chart. That is normally the process I do. I get the subnet addresses. I fill those in. Then I come over here to the broadcast address, which is 1 less than the next network address. I can go through and fill that in. And then I fill in the first usable and last usable last. I keep those in the center because all you have to do is add 1 to the subnet address. That gives us our first usable. And then for the last usable, all you have to do is subtract 1 from the broadcast address. That gives us our last usable address. That's how I fill in these tables. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. If we look at our topology, we can see assigned subnet 0. That would be the first subnet from up here in this chart we just filled in. To the LAN connected to the gig Ethernet 00 interface on R1. What I'm going to do is locate R1, router 1. That is this device right here. The LAN connected to the gig 00 interface, that's right here. And so what we're looking at is this network right here. We want to use that first network, subnet 0, on this network right here. And what we want to do is assign it. And what I'm going to do is just write it down. So we're going to look up here. Our first network here was 192.168.100.0. And then you should always get in the habit of writing down your subnet mask. Now I could either write it as 255.255.255 dot, and we can go up here and look, .224. We could write it that way. Or you could write it this way, 192.168.100.0. That is our subnet, our network address again. And then you could put it as a slash number. Coming back up here to look at our binary of our new subnet mask. We have 8 ones and 8 ones again and 8 ones again. And we're borrowing 3 bits. This is our full network portion. All of these across here. 8 plus 8 is 16, plus 8 is 24, 25, 26, 27. That is a slash 27 address. Coming back down here to step 2, 190, our answer for A, 192.168.100.0 slash 27. This is the, well, I'm missing it. That should be a 224. This is the preferred method. This is the way, it's just a little bit shorter to write, a little bit quicker, and anybody in networking, they understand that. This is the method I'm going to continue working through. Step B, assign subnet 1 to the gig Ethernet 01 interface on R1, that is, we are looking at this network right here. This is R1, this is the gig 0 interface. This network, the network with PC2, switch 2, we're going to assign subnet 1, or our second network. That's right here, 192.168.100.32. 192.168.100.32, and it's the same subnet mask all the way down for all of these networks. It's the 255, it's the 255, 255, 255, 224, or it's a /27. And like I said, I will use the /27 at this point because I prefer that method. Assign subnet 2 to the LAN connected to the gig 00 interface on R2. Once again, we are looking at this network right here. The one with PC2 and switch 2 in it. We are looking at this network right here. That gets subnet 2, our third network. That is 192.168.100.64. 192.168.100.64/27. Assign subnet 3, the fourth subnet, to the LAN connected to gigabit Ethernet 01 on R2. That would be this network right here. The one with PC4 and switch 4 in there. That's this network right here. That gets subnet 3, our fourth network, 192.168.100.96. 192.168.100.96. And once again, same subnet mask /27. And then for the fifth network we have, once again, remember, we do have a fifth network here. Assign subnet 4, our fifth network, to the WAN link between R1 and R2. We are looking at this right here, this connection. The serial connections between R1 and R2 at this point in time. Fifth subnet. Subnet number 4 starts off with 192.168.100. Scroll to our chart. Here's subnet 4, our fifth one, 192.168.100.128. 128. And then once again, same subnet mask. It's a /27. There we go. We have assigned network addresses to all of these 5 networks in our topology. Step 3, document the addressing scheme. Fill in the addressing table. Once again, the addressing table is up on top using the following guidelines. Assign the first usable IP address in each subnet to R1 for the 2 LAN links. These are the 2 LAN links right here. What we're looking at, G00, G01. So we want to put the first usable IP address on these 2 when we fill in our addressing table. And also the WAN link gets the first one. So serial 000 here gets the first usable IP address of this network. Assign the first usable IP address in each subnet to the R2 interfaces. That's gig 00 and gig 01 down here. Those assigned addresses that we just did the step before, give them the first usable IP address there. Assign the last usable IP address for the WAN link. This is the same network here. Up here, R1, we're using the first usable. Down here, we're going to use the last usable on this network. Then we're going to assign the second IP address to the switches in each subnet. So looking here, each of these 4 switches is going to get the second usable IP address. And then the last usable IP addresses are going to get assigned to the PCs. Okay, we do have a bunch of information to fill in the chart. First one, assign the first usable IP addresses in each subnet to the LAN links on the routers. Coming up here. Here is our LAN link. R1, this is the first network here. That got our first network. And so I'm going to wind up doing a lot of scrolling up and down. This was our first network, subnet 0. The first usable address we can get right from the chart here, 192.168.100.1. Scroll up here, 192.168.100.1. And the subnet mask. Now, as we fill in this chart here, remember the subnet mask was always a /27, but when we fill in this chart, because we're going to be putting these in, we're going to be programming the router, the PCs, they don't understand slash numbers, but they do understand the decimal equivalent of that. And so what we're going to put here is this address, 255.255.224 as that. Coming back here, our subnet mask is 255.255.255.224. This being a router, this being R1, does not have a default gateway. It is the default gateway for these local area networks, but the router itself does not have a default gateway. So this is basically, it's non-applicable at this point in time. Then we go to the G0 interface. We are looking at this network right here. We assigned it the second network. So I scrolled down here pretty quick. This is subnet 1, our second network. This was the first usable, 192.168.100.33. We'll assign the first usable address there, 192.168.100.33. The subnet mask, once again, subnet masks are all the same. We're borrowing the same bits for all of these subnets, our smaller networks inside of our one bigger network. And what we could do is we could actually just copy this here. And what we do is we can paste that into every one of these fields because, like I said, we have the same subnet mask. Have the same subnet mask. Go ahead and paste that right in there. And once again, this router doesn't have a default gateway. It acts as the default gateway for these local area networks over here, but the router itself does not have a default gateway. So any connection here does not have a default gateway. And I'm just going to put NA in all of these fields for router 1 and router 2. Now all I have to do is fill in the IP addresses here. The IP address for R1 serial 00 interface is right here. If we scroll down, it said use the first assignable address for the WAN link also. The WAN link was assigned to subnet 4, which is our fifth one. Subnet 4 is right here. If we come over to here, our first usable here was .129. So scroll up to our addressing table, 192.168.100.129. We filled in the subnet mask and the default gateway because there is none. There we go. We have our addressing done for R1. Now we're going to go ahead and do the addressing for R2. R2 gig 00 is this network right here. The network that's got PC3 in it, S3 in it. Coming down here. Once again, looking at this, assign the first usable IP address in each of the subnets on R2 to the LAN links. Coming up here, we assigned subnet 2 to the gig 00 interface. That's what we're working on. Subnet 2, our third subnet, is right here. Our first usable address, 192.168.100.65. Scroll up. We can put that address right in here, 100.65. Subnet mask already filled in. Next, we fill in our gig 01. Gig 01 is this last local area network. That's the one right here. If we scroll down, we assign gig 01 interface to subnet 3, our fourth subnet. Coming up here, this is our fourth subnet. This is our network address. This is the first usable. Our first usable, 192.168.97. Scroll up to our chart here, 192.168.100.33. 97. And then we have our serial 00 interface yet. That is this other end of this connection. That is our WAN connection. Remember the instructions said use the first usable address here, use the last usable address down here. The subnet that connects R1 to R2 is subnet 4, our fifth one. That'd be right here. Here's our network address. This is the first usable. We also calculated the last usable, 192.168.100.158. This is the address they are asking for, the .158. Let's scroll up here. We have 192.168.100.158. That takes care of all the addressing for our routers. Now we have to address our 4 switches. Our 4 switches said assign the second usable IP address in the attached subnets to the switches. Okay, subnet 1 is right here. It's got S1 in it. If we come up here, our first subnet, and sorry, that's subnet 0, our first subnet, our first usable IP address was 192.168.100.1. Add 1 to it, that turns it into 192.168.100.2. That gives us our IP address for VLAN 1 on switch 1, 192.168.100.2. Oh, I'm missing a period right there in the line above it. For switch 2. Come on down here, switch 2. Oh, we can look over here on our topology. Switch 2 connected to the gig 0 interface. We know that is our second subnet, subnet 1. Here's our information in our subnet table. Subnet 1, our second subnet. That's our network address. Can't use that one. This is the first usable. We are looking for the second usable for our switch. Add 1 to .33. That gives us .34. 192.168.100.34. Switch 3, VLAN 1. This is switch 3 right here. It's on the third network, or subnet 2. Once again, remember subnet 0 is the first one. We're on the third one. Let's scroll down to our subnet table. Here we have subnet 2, our third subnet. Our first usable was .65. Add 1 more to get our second one. That gives us .66. Scroll back up. Let's fill that information in. 192.168.100.66. And then for the last switch, switch 4. That is in the fourth subnet. Subnet number 3. Scroll down to our subnet table. Here's our fourth subnet, subnet number 3. First usable, 192.168.100.97. That's first usable. We want second usable. Add 1 more to that. Gives us .98. 192.168.100. Is that a dot in there? .98. What we need to do also is for our switches, we have to specify the default gateway. The default gateway is the router address. That is our exit on and off of our network. For this first LAN right here, LAN 0, this is our network. This is our default gateway right here. This interface. We gave the LAN interface on these routers the first IP address. Or we can look back up here. This is gig 00 on R1. This is our default gateway address, 192.168.100. That goes right here, 192.168.100.1. S2 is on this network right here, the one with the gig 01 interface. If we go up to R1 here, look at gig 01 interface. This is our default gateway address, 192.168.100.33. 192.168.100.33. Switch 3 default gateway. Here, this is the network switch 3 on. It's got on R2 now we're looking at the gig 00 interface. Come to our addressing table. Here's R2, the gig 00 interface. This is the IP address, 192.168.100.65. That is our default gateway for the third network. And finally, switch 4 is on our fourth network. It is our network 3. Once again, remember, we start counting with 0. We are looking at the G01 interface on R2. Come up to here. Here's R2. The gig 01 interface has this IP address, .97 at the end. That is our default gateway, 192.168.100. What was it again? .97. There we go. Okay, that leaves us with our PCs left to figure out this addressing table. Coming down here, once again, what's the requirement? Use the last usable IP addresses to the PCs in each subnet. Well, this is where this table is going to come in handy again, because for each subnet, we figured out what the last usable host IP address was. And this would be the IP addresses of our PCs in there. PC 1 is on our first subnet, subnet 0. The last usable IP address, here's our subnet, our first subnet, subnet 0. The last usable IP address, 192.168.100.30. That is our IP address of PCA, .30, 192.168.100.30. Then we also need to fill in our default gateway. Our default gateway is our exit on and off the network. Once again, here's PC1. It is right here is our exit on and off the network. It's our G00 interface on R1. We can easily look up here. This is R1, G00 interface. This is our default gateway, 192.168.100.1. 100.1. Notice both switch 1 has 100.1 and PC1 has the same default gateway. These two devices, they're on the same network. Because they're on the same network, they have the same default gateway, same exit on and off of the network. That is how it is intended to be. PC2 is on our second network. Our second network, subnet 1 here. Here we go. This is our network address. First usable, last usable is right here. 192.168.100.62 is our PCB address. 192.168.100.62, our last usable address in that second network. And our default gateway. Once again, this is our network. This right here is the interface that is our default gateway. Gig 01 on R1. Here's R1. Gig 01. And then this is our address, 192.168.100.33. 192.168.100.33. PC3. PC3 is on our third network, network 2. So we want the last usable on subnetwork 2. Down here, here's our third network, subnet 2. Network address .64. First usables .65. Last usables .94. This then is our IP address of PCC. .94. 192.168.100.94. And then we have to figure out what our default gateway is. Once again, this is the network we're looking at. PC3, switch 2. We are looking at this interface right here. The gig 00 interface on R2. That is our exit on and off of our network. That is our default gateway. Here's R2. Here's our gig 00 interface. This is the IP address assigned to it. This is our default gateway. 192.168. Where were we? .100.65. Our final line in this addressing table is PC4. PC4 is down here. That's on our fourth network. Subnet 3. Scroll down to our subnet table once again. Here is our fourth. Here's our fourth network. Subnet 3. Network address is .96. First usable .97. Last usable is .126. This is our PC4 address, 192.168.100.126. Let's scroll up here. 192.168.100.126. Then we need to figure out what our default gateway is. Once again, this is it. This is our connection. This is our exit on and off of this local area network, G01 on R2. Here is R2. Here is gig 01. This is the IP address for it, 192.168.100.11. This is our default gateway off of our local area network. 168.100.97. And that fills out our addressing table. We are able to get that all from our system requirements. Number of LANs, number of devices, and then what IP addresses are we assigning where. That gave us the ability to fill in that entire chart. Part 2, assign the addresses to network devices and verify the connection. Part 1, we figured out what our addresses were. Now part 2, we're going to go ahead and assign them. Most IP addressing is already done. In this Packet Tracer lab, a lot of this IP addressing is done already. What we have to do is implement the following steps to complete it. ERGRP, a routing protocol, is already running on these two routers. And that's configured between the connections here. They'll share network information back and forth. Step 1, configure the R1 LAN interfaces. What we're looking for is our R1 here. We're going to configure these interfaces right here. Configure both LAN interfaces with the addresses from the addressing table. We got to configure G00 and G01. And then configure the interfaces so the hosts on the LANs have connectivity to the default gateway. Meaning we need to turn the interfaces on at that point in time. Go ahead and click on R1 here. Going to go in our CLI. I just automatically expand this window out. I hit enter several times to give us some clean working area. And so we have to configure IP addresses on G00 and G01. We need to get into privileged exec mode. Go ahead and type enable, hit enter. Now we're going to make changes to the configuration. We need to get in global configuration mode. Once again, that is config T. Go ahead and do that. Notice our prompt has changed. We're going to work on gig 00 interface first. Command is interface or int space g/0/0. Our prompt has changed again. Our prompt has changed again. Signify we are working on an interface. We want to assign the address here. Let's scroll up. Our addressing table. On R1, the G00 interface, this is the IP address and the subnet mask. To set the IP address, it is IP space address. Oh, I got an extra character in there. IP space address space, and then we can get our address from the addressing table. 192.168.100.1. And because we are setting an IP address, we also need to set or specify the subnet mask. Our subnet mask here is the 255.255.224. 255.255.224. Go ahead and do that. And we have to turn on the interface so our devices can connect to that. Once again, the command to turn it on is no space shutdown. Once again, as we complete stuff, you can see that our completion percentage down here is increasing. I haven't hit entered. I'm going to go ahead and enter. Completion percentage is at 20%. I did no shutdown. We are now at 23%. We do get a status update. Gig Ethernet status is changed to up, so the port has turned on. Line protocol is now changed to state up. We are running IP version 4 on there. I'm going to go ahead and enter a couple of times. We now need to set our IP address for our gig 01 interface. At this point in time, I don't need to exit out. I can just change interfaces. So I go ahead and type int space G0/1. The interface changed. There's no confirmation, but because we didn't get an error, we know it's successfully completed. Our G01 interface, here's our IP address. I'm in our addressing table, 192.168.100.33, and our subnet mask. Go ahead and set our IP address. The command once again is IP space address 192.168.100.33, and because we are setting an IP address, we need to specify our subnet mask 255.255.224. Sets that, turn on the interface, no space shutdown. And my completion is now at 46%. Interface gig 01 has now went up, line protocol has now went up. We need to do R2 with these addresses. I'm going to go ahead and minimize R1 window. Oh, no, let's go down and check our instructions. Our instructions now say configure both LAN interfaces on R1, configure the interfaces. So we set the IP addresses for this. We turned on the interfaces here. Once again, the router is the default gateway, so the host can actually connect to the default gateway. We need to turn it on. We are on to step 2, configure the IP addressing for switch 3. Switch 3 is right here. I'm going to go ahead and click on switch 3. I'm going to slide it over a little, make the window a little bit bigger, click on our CLI tab. There we go. Hit enter a couple times, gives us a clean working area. On switch 3, configure the switch VLAN 1 interface with addressing. Configure the switch with a default gateway address. We need to go into the interface VLAN 1 and set the IP address on switch 3. We scroll up to our addressing table. Right here is switch 3, VLAN 1. This is our IP address, 192.168.100.66. Here's our subnet mask, once again, 255.255.255.224. And our default gateway, our exit on and off of the network. That's the router interface. Okay, over in our CLI, I'm going to go into privilege exec mode by typing enable. Go into global configuration mode, config T. We are working on the interface of VLAN 1. INT space VLAN 1 changes our prompt saying we are working on an interface. It just happens to be virtual LAN 1. Here we can set our IP address, which is 192.168.100.66. IP space address space 192.168.100.66. And because we're setting an IP address, we need to put the subnet mask of 255.255.224. Go ahead and set that. Do a no shutdown on it. Change state went to up. Line protocol is up. All good things. Last thing we have to do is set our default gateway. Once again, the default gateway applies to the entire device, does not apply to a specific interface. So we need to back out of the configuration of the interface. Go ahead and type exit once. Takes us to global configuration mode. Once again, you can tell that from our prompt. To set the default gateway, it's IP space. Don't remember exactly what it is. Put it in a space question mark. Command right here is default gateway. DEF. I use tab to do tab completion. And then we put in the IP address of our default gateway. This is the IP address of our default gateway. 192.168.100.65, the first usable IP address. Now, because we are pointing it to an established IP address, it's already been configured, we don't have to put the subnet mask on there. We don't do that. We just do IP space default gateway space and then the IP address for us it's 192.168.100.65 and then hit enter. We don't have to put the subnet mask in there. If you do, you're going to get an error. And there we go. We have configured that. and our completion percentage, we are up to 80%. Let's scroll down here. That took care of step 2. Step 3, configure PC4. Configure PC4 with the host, with the IP address and the default gateway. Okay, let's scroll up to our addressing table. PC4 is our last here, our last line in our addressing table. This is our IP address, this is our subnet mask, and our default gateway. I'm going to go ahead and minimize our S3 window. Click on PC4 at this point in time. Over here on our desktop tab, I clicked on desktop here. I click on IP configuration. Make sure underneath IP configuration, not IP version 6, but just under IP configuration, that's IP version 4, static is selected, and we can go ahead and enter in our information. Once again, our IP address, 192.168.100.126, 192.168.100.126. And notice our completion does not go up until I click out of the field. I'm still in the IP address field. We're at completion of 80%. I'm going to click in the subnet mask field. We are now at completion of 86%. So you have to click out of the field to have it be graded. Our subnet mask, it gave us the /24, the default subnet mask, but we did some custom subnetting mask. We subnetted, we created smaller networks of our one bigger network. And so this is our subnet mask now. 255.255.224. We need to change the last octet from 0 to 224. Go ahead and click in a different field. Takes us up to 93% completion at that point. And then the last step is we need to set our default gateway. Here's our default gateway. Once again, exit on and off the network. That is the IP address of the gig interface that on router 2. Here's our default gateway, IP address of 192.168.100.97. As soon as you click out of that field, updates it. I am at 100% completion. Let's scroll down here. That takes care of step 3. Step 4, verify the connectivity. You can only verify connectivity from R1, S3, PC4. However, you should be able to ping every IP address listed in the table. What they did is only gave us access to R1, S3, and PC4. And so what I'm going to do is from PC4 here, I'm going to open up PC4. I'm going to open up the command prompt. I'm going to scroll up to our addressing table, and I'm just going to ping these addresses. Starting off with R1, gig 00 interface, ping 192.168.100.1. That works. Go down, ping the next one right here. PING space 192.168.100.33. Oh, I put it in 2 decimal points. Let's correct that. There, that's working. Now we'll go ahead and ping the serial interface on R1. PING 192.168.100.129. That's working beautifully. Now we'll start pinging R2. Ping 192.168.100.65. There you go. That one works. Now we'll ping the G01 interface. Ping 192.168.97. Oh, sorry. .100.97. There you go. That's working. And now we'll ping the serial 000 interface on R2. Ping 192.168.100.158. There you go. We have now successfully pinged R1 and R2. Now I'm going to go through and I'm going to ping switch 1, 2, 3, and 4 and the other PCs. We are right here looking at this address. Ping 192.168.100.2. There we go. We had to do our process several times. And so we had to take the IP address 192.168.100.2, resolve it to MAC addresses, and then we can ping it. If I ping that address again, up arrow is my friend, all 4 will work. I was a little nervous there, but it worked. Now we'll ping switch 2 VLAN 1. Ping 192.168.100.34. Gonna have to do some ARP. I don't know how much. We are waiting. Still. There we go. Up arrow again just to test it. Make sure all 4 successfully work so we can ping switch 2. Let's ping switch 3. Ping 192.168.100.66. Odds are we'll have to have 2 failed pings again. That's 1. That's 2. Should start working. Up arrow to repeat that. All 4 are going to work. Let's ping the last switch, switch 4. 192.168.100.98. If I had to predict, it's going to fail the first 2 pings because it has to do the address resolution. Oh, we only had 1 failed ping. There we go. Up arrow again to repeat it. All 4 will work. Let's go ahead and ping PC1. PC1. 192.168.100.30. That was the last usable IP address. We're going to have to do an ARP process here. Maybe request once. Worked all 3. I'm going to repeat it one more time just to make sure all 4 worked. There we go. Ping PC2. Ping 192.168.100.62. Do the ARP request. Probably fail once. There it is. 3 out of 4. I'm going to just repeat it. Make sure all 4 work. There we go. And let's ping PC3. 192.168.100.94. Going to fail the first time. Next 3 are going to work. Repeat that ping just to verify all 4 are going to work. And so we have pinged every device on the network from the PC. I'm saying we've got great connectivity at that point in time. Scroll down to the bottom here, and we are done. That was Packet Tracer Lab 11.7.5 Subnetting Scenario. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.